Today we're going to continue on with sequence and series with 12.2. And in 12.2, we're going to talk about a specific kind of sequence and series called arithmetic. Okay, and this is going to have its own equations, its own set of rules. And then in 12.3, we're going to talk about another one called geometric. But today we're going to start with the arithmetic sequence and series. Now, also today in class, I want to make sure and show you how to do these summations in your calculator. Because when you look at an example like this right here, you wouldn't want to do this by hand. You wouldn't want to start at 5, plug it in for n, and then plug in 6, 7, 8, 9, 10, all the way to 35. That would take you forever. So I'm also going to show you how to do this by using your graphing calculators today in class. Now, going back to 12.2, the arithmetic sequence and series. The arithmetic sequence is the difference between consecutive terms is going to give you a constant. Now, consecutive is one after another. So when you're looking at your terms, the difference between them is constant. So you're adding 2 every single time, or you're subtracting 5 every single time. But the difference stays constant. Okay, and this constant difference is called the common difference, denoted by D. Okay, and that's going to be important, making sure you know that difference notation is that D. Now, if we think about what we've been doing, we have a y equals mx plus b that we've referenced with an a sub n equals, and you can write this in many ways, 2n minus 3, or however we have it. And what have we said? This 2 is, it would be going up by 2 every single time. That's what we're talking about up here with this common difference, this d. So this common difference is just like that slope that we've been talking about in 12.1. Now, let's look at these examples down here. Decide whether the sequence is arithmetic or not. Okay, well, what did we say? In order to be arithmetic, there has to be a common difference. So look at A, -3 to 1 to 5 to 9 to 13. What is happening as we go from term to term? We're going up by 4. Does it ever change? Is it ever not 4? No. Every single term goes up by 4. So is this arithmetic? Is there a common difference? Yes. And then if I asked you, what's D? What would you tell me? D would be 4. How about the next one? 2 to 5 is plus 3. 5 to 10 plus 5. 10 to 17 plus 7. 17 to 26 plus 9. So is there a common difference? No. So no, this is not arithmetic. Now, we have an arithmetic equation that you see up here at the top. A sub n equals a sub 1 plus n minus 1 times d. This is your arithmetic equation. So anytime you're wanting to find your arithmetic equation, this is what you're going to use. Now, there's 2 things that you need to know. You need to know a sub 1 and you need to know d. D we just talked about. That's that common difference, just like your slope. A sub 1, what does that mean? If it's a sub 1, that's the what term? That's the first term. That's what this 1 means. Remember, position 1. So that's going to come from your first term in your sequence. Okay, well, let's look at our example. Write a rule for the nth term of the sequence 50, 44, 38, 32, ... then find a sub 20. Okay, well, we're going to forget about this for a minute because you have to have a rule or an equation in order to figure out what a sub 20 is. Okay, so write the rule. Well, we just said 2 things. We need to know d and a sub 1. Well, a sub 1 we already know. A sub 1 is our first term, so a sub 1 is 50. So we're going to plug in 50 for a sub 1. And then we need d. Well, what's our difference? 50 to 44 to 38 to 32. So our difference is we are going down by 6. That goes in for your d, down by 6. And if you know a sub 1 and you know d, all you have to do is plug them in and then solve. What is -6 times n? -6n. -6 times -1 is +6. So what's our equation? -6n and 50 and 6 gives me 56. So our equation would be 56 minus 6n. And then going back and trying to find a sub 20. What's that 20 mean? That 20 is the 20th term. So how do we find the 20th term? If we have our equation right here, to find our 20th term, we just put 20 in for n. So a sub 20 equals 56 minus 6 times 20, which is negative 64. Now, a couple examples. 21. What do we say we need? We need a sub 1 and we need d. A sub 1 is where we start, our first term. So a sub 1 is 1. And then d, what's our difference? 1 to 3 to 5 to 7 to 9. So what's our difference? Plus 2. Plug them in and solve. 2 times n is 2. 2 times negative 1 is negative 2. So what's our equation? We have 2n, and then we have 1 and negative 2. So our equation is a sub n equals 2n minus 1. Now, the directions up here say write the rule, which we just did, and then it says then find a sub 25. Okay, so how are we going to find a sub 25? We take n and plug in 25. So a sub 25 equals 2 times 25 minus 1. 2 times 25 is 50. 50 minus 1 is 49. So a sub 25 equals 49. Now let's look at 25. Okay, a sub 1 and d. Again, the two things that we need. A sub 1, first term is 4. And what's my d? 4 to 1, down by 3, to negative 2, down by 3, to negative 5, subtract 3, negative 8, subtract 3. So d is negative 3. Pull it in, negative 3n. Negative 3 times negative 1 is 3. So what's our equation? A sub n equals negative 3n plus 7. Find a sub 25. Again, how do we do that? Plug in 25 for n. So negative 3 times 25 is negative 75 plus 7 is negative 68. So that's the basics. That's the easy method for the arithmetic. When you have a sequence, you know your a sub 1, and all you have to do is identify your d. Now, a little bit harder. This question, we want to do the same thing. We want to write the rule, and then we're not going to worry about graphing right now. We have it over to the side, but the big thing is writing the rule. Okay, so the big difference here, we know d. D is 3/2. But they don't give us a sub 1. They give us a sub 13 equals 30. So we know it's arithmetic, so here's our equation. And we don't know a sub 1, so we're going to have to find a sub 1. Okay, so plug in what we do know. We know d is 3 over 2, so we're going to plug that in for d. Then this right here, a sub 13 equals 30. That gives us two pieces of information. When n is 13, what do we get for an answer? 30. So our answer is 30, which is what I just put in for a sub n. And our d is 32. And then what's the last piece of information I can still substitute in here? When is this equal to 30? When n is what? When n is 13. So that's the three pieces of information that I have. My d is 3/2, and a sub n is 30 when n is 13. Now, if you notice, by plugging that information in, the only thing that we still have left to find is that a sub 1, which is what we said we're missing. So all we have to do is solve this to find a sub 1, and then we plug it in just like we did in the last example. Okay, so pull in, or you don't have to pull in. Go ahead and start with your parentheses. 13 minus 1 is 12. And then multiply. 12 times 3/2 is 12 times 3/2 is 18. and then subtract that 18. 30 minus 18 is where we get our 12. So plug them in, do exactly like we did last time. A sub 1 is 12, and they already gave us our D. D is 3 over 2. Pull it in just like we did, 3 over 2n, negative 3 over 2, combine your terms, and your equation is 21 over 2 plus 3 over 2n. Okay, so this one just requires that extra step up here of finding the a sub 1 first. Okay, and then graphing just like we did the other day. How do you graph? You just plug in your terms. Plug in 1 and see what you get for an answer. Plug in 2, see what you get. Plug in 3, see what you get. And you should get a line. That's why these are arithmetic. They have a common difference, so they're going to give you a line. So let's look at 2 more. 30. D is 4, so we can plug that in. A sub 14 equals 46. So we're missing a sub 1. So we're going to have to find that. But this tells me 2 things. What does this tell me? When a sub n is 46, when the whole thing is 46, where does this 14 go? N is 14. So D was 4. That goes over here. And when n is 14, I get an answer of 46. Okay, so now let's solve for a sub 1. 14 minus 1 is 13. 13 times 4 is 52. Subtract that 52. So what's a sub 1? A sub 1 is negative 6. Now, we have our equation that we're going to have to plug it into. So this negative 6 goes back into my a sub 1. And we already know our D. We already said our D was 4. So now find your equation. Now that we know a sub 1, find your equation. Pull your 4 in, 4n minus 4. So what's our equation? 4n minus 10. Okay, now let's look at 34. D is negative 6. Okay, so we're going to pull that negative 6 into our D. And this tells us 2 things. We get an answer of negative 4 when n is 12. So we get an answer of negative 4 when n is 12 and our D is negative 6. Well, 12 minus 1 is 11. 11 times negative 6 is negative 66. Add your 66. A sub 1 is 62. Okay, again, go backwards to find your equation. Now we're plugging that in. So we needed A1, we didn't have it, so now we're plugging it back in. So A sub n equals 62 plus n minus 1, and we already said our D was negative 6. Pull it in to get our equation, negative 6n plus 6. So 62 and 6 give us negative 6n plus 68. So depending on the type of information that you're given will depend on how many steps you have to do. Okay, but A sub n is our general rule. Okay, and remember again, the arithmetic sequence has to have a common difference. So those gaps between your terms have to stay constant. They have to stay the same. So here's your homework for today, and then next time around, we're going to be talking about the geometric sequence.